Electric trucks suck at towing. That's not actually true. From a capability standpoint, towing is rather effortless for plenty of electric trucks on the market. But there's a pretty big asterisk here, because when it comes to long-distance towing, EVs struggle. 4 years ago, Tesla, who has absolutely dominated the EV market in the United States, announced a product that had the potential to change the narrative on the story of towing, the Cybertruck. And 4 years ago, I explained why I didn't think it'd be successful in doing so. Not because I doubt Tesla's capabilities, but because there are fundamental challenges when it comes to an EV towing a trailer long distances. But today, I've never felt more optimistic about this problem being solved. We're actually getting very, very close. Surprisingly though, it's not the market leader that's pushing that boundary. So we're going to split this up into 4 sections. First of all, Car and Driver has a really cool test that demonstrates what the problem is. Mercedes then has a really cool test that explains why the problem exists. And then we're going to look at the Tesla Cybertruck as well as the Chevy Silverado EV in terms of long-range towing. So let's start off looking at some of the existing options out there if you're trying to tow with an electric vehicle. You've got the F-150 Lightning, you've got the Rivian R1T, and you've got the GMC Hummer EV. Now all of these have a range in the low 300s, pretty similar as far as their range. However, they have very different battery sizes. So the F-150 and the R1T with the battery around 130 kilowatt hours versus the Hummer EV about 210 kilowatt hours. So why is their range about the same even though they have very different battery sizes? Well, if you look at the EPA road load data, this explains why that is. The Hummer isn't very aerodynamic, it weighs an incredible amount, and it has massive tires. And all of this translates into a really inefficient vehicle. And so if you look at that road load data, again, for a Rivian versus a Hummer at 80 miles per hour, the Hummer has nearly double the resistive force at that speed, meaning it takes about twice as much energy at 80 miles per hour for the Hummer to travel down the road than it does the Rivian. But something really interesting happens when you start towing. So what Car and Driver did is they took these 3 trucks, they hooked them up to a 6,100 pound trailer, and they traveled at about 70 miles per hour on a highway loop to see how much range these vehicles had. Now the results are pretty wild. The F-150 only had about a third of its claimed EPA range while towing. Once it was towing, it cut back that range so much. And the same story really occurs for the Rivian as well. So both of these dipping from low 300s to now about 110 miles while towing. An insane drop. But the Hummer didn't quite see that same drop. It goes from 329 down to 140 miles. And so why do we have these percentage differences where the F-150 is getting 33% of its range, but the Hummer is getting 43% of its claimed range? And the easy answer is, well, it has a larger battery, right? So it's able to tow farther. But that doesn't explain why that percentage drop is so much different for the F-150 and the Rivian versus the Hummer. Mercedes, however, conducted a fascinating study on electric vehicle towing that explains why this occurs. So what Mercedes did is they compared the aerodynamics of an electric sedan versus an electric SUV. First, without a trailer attached. And so what they found is that the coefficient of drag multiplied by the frontal area of the sedan turned out to be 0.61 meters squared. For the SUV, that turned out to be 0.95 meters squared. Now you don't really need to know what these numbers exactly mean. All you need to know is that what this means, the difference between these two, is that if both of these vehicles are traveling down the highway at the same speed, the SUV is going to have about 50% more aerodynamic drag versus the sedan because its CDA is about 50% higher. So what happens when you then attach the same trailer to both of those vehicles? So for the sedan trailer combo, the CDA increased to 2.14 meters squared, or an additional 250%. Now for the SUV, it increased 2.09 meters squared, just an additional 120%. So as you can see, with the trailer, the SUV, despite having much worse aerodynamics than the sedan, is actually more aerodynamic while traveling down the road than the sedan combined with the trailer. Alright, so what in the world is going on here? Why would a vehicle that has worse aerodynamics than another vehicle suddenly have better aerodynamics once towing? So a lot of this comes down to the vehicle's wake. So the SUV, because it's a larger vehicle, it has a large wake behind it. And as a result, the airflow doesn't really stack up in front of this trailer. So you have a small high pressure region on the front of this trailer versus the sedan, which has a small wake, a lot of that airflow coming up and back down over and then ramming into the front of this trailer. It creates a large high pressure region on the front of that trailer. And in Mercedes' study, they found that that high pressure region was the largest contributing factor as to why that CDA increased so much. What this demonstrates is that towing is the great equalizer. Maybe you created a really aerodynamic vehicle, but once you start towing, you're at the mercy of that trailer as far as aerodynamic losses. So you've probably heard electric car companies say things like, hey, anybody can use a larger battery. We like to work smarter, meaning creating a very efficient aerodynamic vehicle so that you don't need a massive battery. Now that's absolutely true when it comes to a vehicle on its own. But once you start towing, it is all about the size of the battery, because again, towing here is the great equalizer, as demonstrated between this sedan and this SUV. All right, so how does this relate to the Tesla Cybertruck? For a pickup truck, the Cybertruck is actually pretty aerodynamic, but what this could mean is that you have that airflow come back and then ram into the front of that trailer and thus create that large high pressure region, reducing the aerodynamic efficiency of the overall unit. So if you were to use a more traditional pickup style, you may have a larger wake, thus meaning while towing, you get better aerodynamics. So if you were to design a vehicle that you knew was always going to be towing, you'd probably design it differently than if you were to design a vehicle that wasn't always to be towing. Now obviously, for most users, most of the time you probably won't be towing, so that seems like the obvious choice in which to optimize for. But it is worth pointing out that this is probably going to be a challenge for the Tesla because it's so aerodynamic. So what is the Cybertruck's towing range? Well, I was trying to find a test that was similar to what Car and Driver did, and I found one by TfL Truck where they were looking at the Cybertruck on the highway at about 60 miles per hour with a 7,000 pound trailer. Now they were getting an efficiency of about 900 watt hours per mile, and if you have a 123 kilowatt hour battery, divide that by 0.9, that gives you a total towing range of 137 miles. Now if you adjust that from 60 miles per hour to about 70 miles per hour using the EPA's road load data and doing a bit of guesstimating there, it gets you in the range of 110 miles at 70 miles per hour. So very similar to both the F-150 Lightning and the Rivian R1T in terms of towing, and that, again comes down to it has a similar battery size. Now, Tesla has said that they're going to release a range extender for the Cybertruck, which will bring its range from 340 miles EPA rating to about 470 miles. Now, these ratings are generally a bit higher than what you'll actually get in the real world, but regardless, doing some quick math, you can estimate that battery pack, the additional range extender is going to add about 50 kilowatt hours, giving you a total of about 173 kilowatt hours for the truck. In other words, in these range tests, it'd be getting around 160 to 190 miles. Now the downside here is that this range extender is actually taking up some of the bed space, so you're losing a big part of the functionality of your truck. So you're sacrificing bed space, and your real world towing still isn't an incredible number. It's certainly better than what we're getting with today's options, but it's still not that great, all things considered. The key takeaway here, though, is that it's all about the battery, which leads us to the Chevy Silverado EV. Now, we don't actually know the size of the Silverado EV's battery pack because for some annoying reason, manufacturers have decided that they no longer need to share useful information with consumers or the media. Now you have to dig through EPA filings to try and figure this stuff out. However, there was a test, another test done by TfL Truck, where they took a Silverado EV, charged it up to 100%, and towed a 6,500 pound trailer to see how far it could get. And the result is very impressive. They were able to travel 232 miles while towing a 6,500 pound trailer, and they still had 15 miles of range remaining as indicated by the onboard computer. They used a total of 205 kilowatt hours with an average efficiency of 1.1 miles per kilowatt hour, which would give you about, considering the extra battery remaining, a battery size of about 218 kilowatt hours. Now, another test they conducted was on the highway to see what's this thing's range without a trailer. They took it from 81% battery down to 57% battery using about a quarter of the battery, and in that quarter of the battery, they traveled 128.4 miles. So, if we take 128.4, we divide that by 0.25, that gives us a total range of over 500 miles. Absolutely incredible, the range on this electric truck. Very impressive to see. And if you do the math there to figure out what's the size of the battery, well, it gives you something around 223 kilowatt hours. Now, both of these numbers do not take into consideration regen. So as you're putting more energy back into the battery pack as you're regenerating and then using that, you could get an inaccurate reading of the overall battery size. There's not going to be a ton of that, especially while towing, if you're staying at a constant speed on the highway, but regardless, it's something to take into consideration. So, it is possible this battery pack is basically the same as the Hummer, about 213 kilowatt hours. But again, that's still 40 kilowatt hours more than the Cybertruck with the range extender. And if you're towing, the bigger the battery pack, the better. So that is exciting to see. And hey, with the Silverado EV, you still have full use of the truck bed even with that larger battery. So electric vehicle towing is an interesting challenge. The way I think about it is, from the manufacturer's standpoint, their biggest goal is to get consumers to buy the vehicles. That's tough all on its own. But in order to convince any truck buyers who tow to go electric, I think you have to address three fundamental challenges. First, there has to be a truck capable of long-range towing. Second, there needs to be a charging infrastructure that allows for EV towing. And third, the price needs to be affordable. In this case, the Silverado EV checks that first box. The range while towing, combined with the crazy fast charging speeds of 350 kilowatts, means technically you can have an electric towing experience very similar to just driving an EV on its own. That is a remarkable step. As far as charging infrastructure, the biggest challenge today is a lack of pull-through options, meaning you have to detach the trailer at many stops, then charge the vehicle, then reattach. In addition, charging speed is critical. If you're limited to 150 kilowatts, like many of today's stations, you could easily spend an hour or longer at each charging stop. Not ideal. But the network is constantly improving, so I don't doubt that solving this is feasible. And finally, regarding price, yeah, electric trucks are expensive, but price parity between combustion and electric vehicles seems to be shrinking, and with volume production scaling up and fuel savings taken into account, this too seems feasible. If you don't need to tow, there are some great EV truck options. If you do need to tow, but only short distances, again, there remain many great EV options. And if you do need to tow, and you need to tow long distances, props to the engineering team at Chevy, as the Silverado EV looks to be the most compelling offering for an EV pickup for those traveling the long haul. If you have any questions or comments, feel free to leave them below. Thanks for watching.